Trapezoid. So if you watched the first video, you know that this is kind of broken down into some very particular steps. So you can see those here again as well. You're going to see a statement of intent. You're going to see, well, first of all, you're going to see a nice graph with some nice labels. You're going to see a statement of intent. Then you're going to see some actual calculations to actually prove what I wrote I'm going to do in the statement of intent. So let's go ahead and get to her. So we want to prove that these 4 points make a trapezoid. That's totally fine. I already graphed them up here and labeled them, so this way we don't just be like this guy, that guy, that guy. We can actually talk about it as far as formal things. So what we need to decide is really what's needed to make this thing a trapezoid, or prove it's a trapezoid. So I know there was some debate in class whether or not a trapezoid should be like exactly one or at least one. But in this case, it doesn't actually matter. We just have to prove that there are parallel lines. So let's go ahead and start with a statement of intent. And again, if you didn't watch the first video, what you're about to see here is just a formal statement of what I'm trying to prove and how I'm going to prove it. Okay, so let's go ahead and start it. So to prove A, B, C, D, just listen to points is fine, is a trapezoid. Now here's where the definition of a trapezoid actually comes into play. So I know a trapezoid, no matter what, how strict the definition actually you want it as far as your class is, in the end it breaks down to showing some parallel lines, and that's what I'm going to show here. So I'm actually going to name them. I will show that AB is parallel to DC. Now this isn't enough because I don't just want to say what I intend to do. I want to tell you how I'm going to do it. So to prove ABC is a trapezoid, I will show that the top and bottom lines are parallel, which is what that symbol means, by comparing their slopes. Now here's the important part. Let's identify what we're looking for. If the slopes are the same, then AB is indeed parallel to DC. Okay, so that was my statement of intent. Like, this is important. Again, if you didn't watch last video, I'd say this is important because this shows and tells the reader that you know what you're talking about. That you know that if you can show that these lines are parallel, then you are in business. And that way, if you mess something up in the next couple of steps in the actual calculation part, at least you're telling us that you knew what to do. It's just somehow you couldn't get the numbers to work out in your favor. Okay, and so that's good for you as a writer. That's good for us as a reader and a grader. But let's get to it. Now, just like before, I want to do some preliminary work actually on the trapezoid, just so I can prove to myself this is actually the case before I proceed. So we can do a very informal evaluation of the slope. And so we can use something kind of like a slope triangle. And so like going from A to B, looks like I go down 1, then over 1, 2, 3, 4, 5, 6. So I go down 1 over 6, which makes this slope negative 1 over 6. Now be careful. I saw some people write 1 over 6. That's not the case. The slope is actually decreasing, therefore negative. And so let's now check out DC. Let's do the same thing. Now this is actually a pretty large triangle, but it looks like we go down 1, 2, 3, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Then we run 18. Well, 3 over 18 is the same as 1 over 6, negative because we're decreasing, so I can at least see up here that I know the slopes are the same. Now that's not good enough for proof. The proof has to be some kind of formal calculation, which means I'll actually have to calculate the slopes. Just like before though, I'm lucky because I know something about slope. I know the slope is actually delta y over delta x, change in y over change in x. I know if I want to calculate the change in y, all I have to do is subtract the y values. So like y1 minus y2, it doesn't actually matter which, you're just looking for a change. And if I want to calculate the delta x, all I have to do is do the same thing in the same order with the x values, x1 minus x2. And so if I actually perform that calculation, I'll actually have a formal calculation for slope. So I want to show the slope of A, B, and DC. So let's kind of do, let's say, one per side. I'll calculate the AB slope here. I'll calculate the DC slope over here. Okay. Now, I need some coordinates to do this because the x1, y1, y2, x2, all that stuff is actually coordinate stuff. So let's grab the coordinates of A and B. And so I can do that maybe just up here. So a is negative 2, comma 1, 2, 3, 4. You can confirm I do have a negative 2, 4 as one of my coordinates, so that's the one I'm calling a, negative 2, 4. Okay. Let's go ahead and grab b as well. Looks like 1, 2, 3, 4, 3. So the b coordinate is 4, comma 3. Again, confirm we have a 4, 3 right there. So we do have an a and a b. Now to use our slope formula, to find the slope, we're going to find the change in y over change in x. So change in y are just a difference of the two y's. My y's are 4 and 3, so that's just going to be a 4 minus 3. I'll be careful when I'm changing my x's to use the same order, top to bottom, a to b, so we have negative 2 minus 4. Now we're just into pure calculation. 4 minus 3 is 1. Negative 2 minus 4 is negative 6. And so my slope is, in this case, negative 1, 6, which is no surprise because I calculated that up here anyway. Going over to DC, again, let's first grab some coordinates for D and for C. So D looks like negative 9, 1, or negative 9, negative 1, and there it is right there. So looks like we're right. And C looks like 9, comma, negative 4, which we have there as well. So 9, comma, negative 4. Let's calculate the slope, change in y over change in x. D going to C, that's negative 1, subtracting off a negative 4. Be careful, you need both negatives there. And the same jump for the x's is negative 9, subtract 9. So negative 1, and this ends up being, of course, plus 4, ends up being a 3. Negative 9 minus 9 is negative 18. If I simplify that, I get negative 1 over 6. So I've now shown that both slopes are the same, therefore parallel. Now, I don't need to write that as a wrap-up or anything because I wrote it in my statement of intent, that red statement. Since I wrote that anyway, I don't have to do anything else. I've now done what I said I was going to do. Journey's over. That one's actually done. We're asked to prove a secondary thing, then prove that it makes an isosceles trapezoid. Give me a second. Let me label these really fast. So A is 2, 4. B is 4, 3. Looks like C, and then D. So we're going order. So to do this, we're going to have to kind of start over. We're going to have to write like another statement of intent. So we have to kind of write what we need to do. Now let's talk about isosceles trapezoid. Isosceles just means two sides of the same length, namely these two guys. If we're looking for length, we're talking distance formula, so that's got to be part of our statement of intent. I think if I can show AD is congruent to BC, we're in business. So let's go ahead and write that out. Here you are. Okay. All right, so to prove ABCD, okay, so to prove an isosceles trapezoid, I will show that, and let's double check to make sure we have the right side lengths. ADBC, okay. I will show that AD is congruent to BC. Now let's tell them how we're going to do it. And I'm going to use the distance formula. Okay. So again, it's important in the statement of intent, like this opening step, that you tell us what you're trying to do on a proved isosceles trapezoid. You're going to tell us how you're going to do it. You're going to use the distance formula, and to tell us what you're going to look for. I'm going to show the lengths are the same. So I'm going to use the distance formula, and if the calculations turn out to be the same, we're good to go. Okay, so let's go ahead and get to that. The distance formula, let's write that first, is just a Pythagorean theorem. That's what we talked about in class, and you practice in Khan Academy. So all we're looking for is a squared plus b squared to be the same. Now you may not have seen it written quite like this. You might have seen it written kind of like this, but if you remember the slope formula discussion we just had, you know delta x is just x2 minus x1 squared, and delta y is just y2 minus y1 squared. I personally never use that formula. I like to think of it kind of as the first one, just distances, because I can usually calculate those in my head. Let me see if I can show you what I mean. So I have to show that AD is the same as BC. So we'll split the formula one either side. So let's go AD. So I know the distance is going to be the square roots of delta x squared plus delta y squared. I don't think I need a formula to tell apart how far apart A and B are. Here's A and here's B. So the x's go from -2 to 9. That's 11. So -2 to 9 is just 11, so that's just going to be 11 squared. The y's are just going from 4 to -4. -4 to 4 is a distance of 8, so I can just square that. So 11 squared is 121. 8 squared is 64. So the distance here is, let's see, 185. Okay, I don't actually need to simplify the square root. I just need to show a distance, and that distance is 185. Let's do the same thing with BC. I think I'm going to need a little more room here, though. Okay, so using our abbreviated distance formula, we have delta x squared plus delta y squared for our distance. We're talking BC. So BC, so BC starts at a 4 and C ends at a -9. So that's a distance of 13. Of course, we'll square it. The y's go from 3 to -1. That's a distance of 4, and of course, we'll square that too. So 13 squared is 169 plus another 16. So 169 plus 16 is 185. And so again, we see the distances are the same. Since we wrote a really nice statement of intent here, this guy right here, since we wrote a really nice statement to begin with, we don't actually have to talk anymore. Like we told them what we're going to do and how we're going to do it. We did that. We're done, guys. And so again, really quick, what you expect to see in a problem like this is, of course, a nicely labeled and drawn diagram. Whatever they're asking you to show, make sure you're writing a nice 3-part statement of intent, what you're being asked to do, how you're going to do it, and how you know you're going to be right, like what you're looking for. Even on a secondary one like this, you see it. I'm going to prove it's an isosceles trapezoid, what I'm being asked to do. I will show that they're congruent by using the distance formula, how I intend to do it, and then I will show their lengths are the same, how I know I'm right. Okay, guys, this is part 2. I think we'll have, about 3 more. I think next one up is going to be a rhombus, my personal favorite. All right, see you guys later.